The first step to solving a simplex tableau is to find the pivot point. Look at the bottom row of the tableau. This row, excluding the values under z and constant, contains the indicators. Look within the indicators for the most negative value. In this case, the most negative value is -4. If, when looking for this value, you find more than one of it, pick the value farthest to the left. Then look at the column that the indicator indicates. For each of the values in that column, divide that value's corresponding constant by the value. So here you divide 2 by 3 to get a quotient of 2/3, and here you divide 6 by 3 to get a quotient of 2. Whichever value gives you the smallest positive quotient, it can't be 0, is the pivot point. If you get more than one of the same positive quotient, choose the one higher up. You should always discard quotients that are 0 divided by 0 or negative. If all the quotients have to be discarded, no maximum solution exists for the problem. So here 2/3 is smaller than 2, so this is the pivot point. Once you have the pivot point, you have to get rid of all the other values in that column, or turn them to 0. This is accomplished with row operations. There are 3 important things to remember when doing row operations on a simplex tableau. Number 1, only use the row with the pivot point in it. For example, if it were in row 2, you wouldn't do R3 minus R1 on R3. You'd have to use R2 and R3 in some combination together. Number 2, you can never do row operations that cause the constants to become negative, because that may cause you to pick the wrong pivot point. Number 3, try not to use row operations with fractions. If you have to do 1/3 R1 plus 1/2 R2, change it to 2R1 plus 3R2. This combination of row operations is called pivoting. After you pivot the first time, you must look at the indicators again to see if any of them are still negative. If they are, repeat the process. Find a pivot point, pivot the tableau, and check again to see if any indicators are negative. When all the indicators have become positive, you're ready to read the solutions. Let's say that this is your final simplex tableau. To read the solutions, first circle all the columns that have all zeros except for one value. You can set up an equation with each of these values and the constant value that's right across from it in the same row. For example, here you have 1 under x sub 1, and across from it the constant 6. So you could set up the equation 1 x sub 1 equals 6, or just x sub 1 equals 6. Here you have a coefficient of 3 under x sub 2, so this would be 3x sub 2 equals 2, or x sub 2 equals 2/3. By the same process, 2s sub 1 equals 6, s sub 2 equals 2, and z equals 19/2. For the columns that aren't circled, the variables that they correspond to simply equal 0. So because this one isn't circled, x sub 3 equals 0. You would interpret these results by saying that the system is maximized at z equals 19/2 when x sub 1 equals 6, x sub 2 equals 2/3, s sub 1 equals 3, s sub 2 equals 2, and x sub 3 equals 0.